Okay, today we're learning about two-sample mean hypothesis testing for z's. This is chapter 9 in your book. The null and alternative hypotheses for this type of test are null hypothesis is going to state that mu1 is equal to mu2, or the population mean for the first sample is equal to the population mean for the second sample. The alternative hypothesis, we still have three choices. We could say that the population mean of sample 1 is less than the population mean for sample 2. Or we could say the population mean for sample 1 is greater than the population mean for sample 2. Or we could stick with the not equal to case. So the population mean of sample number 1 is not equal to the population mean for sample number 2. Here is the test statistic formula that we use to calculate in step number 3. So we take the two sample mean difference, we subtract the two population mean differences, and then we divide by the square root of the standard deviation of sample 1 squared divided by n1 plus the population standard deviation of sample 2 squared divided by n2. That gives us the test statistic, which we use to then find the p-value and make the decision for the test. All right, here's the first example that we're going to walk through together. A new drug is proposed to lower total cholesterol. A randomized controlled trial is designed to evaluate the efficiency of a medication in lowering cholesterol. 30 participants are enrolled in the trial and are randomly assigned to receive either the new drug or a placebo. The participants do not know which treatment they are assigned. Each participant is asked to take the assigned treatment for 6 weeks. At the end of 6 weeks, each patient's total cholesterol level is measured, and the sample statistics are as follows. So we have the sample size for each one, the mean for each one, and the population standard deviations for each one. Is there statistical evidence of a reduction in mean total cholesterol in patients taking the new drug for 6 weeks as compared to participants taking placebo? Use an alpha of 0.05. All right, so first step is we want to write out the null and alternative hypothesis. So our null hypothesis in this case would be mu1, or mu of the new drug, is equal to mu of the placebo group. Mu1 is equal to mu2. The alternative hypothesis, I have to look for any keywords that would indicate a direction. There is a keyword in this one. Is there statistical evidence of a reduction in mean total cholesterol in patients taking the new drug? So we're expecting that this new drug is going to lower cholesterol. So the new drug group should be less than the mean of the placebo group. So mu1 is less than mu2, or mu sub n is less than mu sub p. All right, step number 2, we have a left-tailed test, and our alpha level is 0.05. I would look that up on the Z chart. I'm scanning that Z chart for the closest number in the middle to 0.05, and that's going to give me that critical value. So if we use that Z chart to look it up, our critical value is negative 1.645. Step number 3 is where that formula comes in. Guys, I am going to show the formula for this first one, but we are going to be using calculator functions for this. So Z equals the two sample mean difference. So the first mean is 195.9 minus the second mean, 227.4, minus the difference of the population means, if the null hypothesis is true. So if the null hypothesis is true, that means that the two means are equal. So when I subtract them, it doesn't really matter what their value is. This mean minus this mean, if they're equal, is always going to be 0. So the two mu differences would be 0. Divided by the square root of the first standard deviation, 28.7 squared over n1, which was 15, plus the second standard deviation squared over n2. Again, lots of room for error there, guys, if I was trying to calculate that by hand. So we are going to be utilizing the calculator function. So we go to stat, over to tests. We're looking for the one that says two sample z-test because we do have population standard deviations for this example. I'm going to highlight stats so I can enter the means and the standard deviations. So the first standard deviation was 28.7. The second standard deviation was 30.3. The first mean was 195.9. The first sample size was 15. The second mean, 227.4, with the second sample size, again, 15. Our alternative hypothesis was that mu1 is less than mu2. So I'm going to highlight that second option and then calculate. So our z-test statistic comes out to negative 2.92. And our p-value is 0.0017. I'm going to compare that p-value to our alpha level of 0.05. P is less than alpha. So when p is low, our decision is to reject the hoe. So if we're rejecting the null hypothesis, that means we're getting rid of it and we are supporting the alternative hypothesis. So to answer the question, is there statistical evidence of a reduction? Yes. At alpha equal to 0.05, there does seem to be statistical evidence of a reduction in mean total cholesterol in patients taking the new drug as compared to patients taking the placebo. Okay, guys, here's the second example. Take a look at that. See if you can complete that two-sample Z hypothesis test for this example. Unpause the video to then see the solution. All right, guys, here's the solution to this second example that you try. For step number 1, the null hypothesis, the mean for males is equal to the mean for females. And the alternative hypothesis, since we are not given any directional indication, we would just say the mean for males is not equal to the mean for females. Step number 2, I took that alpha value of 0.01 and cut it in half since it's a two-tailed test. So 0.005 on each tail gives me a critical value of positive or negative 2.575. Step number 3, I did go over to the calculator, stat over to tests, and select the two sample z-test. I'm going to click enter so you can see what I entered in here. So the standard deviations for the populations were given in that first sentence, 14.1 and 9.5. The mean for males was 28 with a sample size of 75, and the mean for women was 33 with a sample size of 50. I selected the not equal to case and hit calculate. That gave me a z-test statistic of negative 2.37, a p-value of 0.0179. Comparing that to the alpha level of 0.01, p is greater than alpha. So p is not low, so we do not reject the hoe. So to answer their question, at alpha equal to 0.01, there does seem to be evidence to support that the population means of concentrations of the element are the same for men and women. All right, guys, that concludes notes for today. Take a look at that assignment and post any questions in the discussion.